Wanted to talk today about I guess our methodology when we test the Seed Terminator mills. So every year we've been able to develop new technology that plugs into the existing Seed Terminators to improve the performance of the mill, that being improving the power, wear, compromise, and also the seed kill. Basically our approach is to try and reduce the numbers of survivors. But I guess one of the confusing things that gets presented a lot is what kill percentage really means, and I guess our approach is a little different. So basically every time we produce a new mill technology, what we do is we have our test stand, which has a conveyor belt, and it has load up that conveyor belt with the known amount of chaff, and we know how fast it feeds into our mill. So we pour the chaff in at a known rate. We apply seeds into that chaff, and we usually apply it in the last half of the chaff pile because we don't want seeds to impact steel without there being chaff cushioning, because that would overestimate the effect of the device. And then we have a capturing system which actually allows the mill to breathe as well. So this is a ventilated capturing system. So set the mill speed up at known speed. We process the material at a known flow rate with the known number of weed seeds, and then we have a sampling technique which we use to create multiple germination samples out of that material. The chaff is mixed with soil in plots, and we've done some tests to work out how much chaff and weed seed mix that you can add in there without affecting the germination, because too much chaff will affect the germination, and that's mostly because the seeds will hide in a piece of chaff, so it won't get wet, it won't have that seed soil contact to wick the water into it. So we also then compare the germination, so the number of seeds that germinate into seedlings, with processed chaff with the seeds added afterwards. So we're looking at a control. So we're looking at if the chaff was processed but the weed seeds weren't, what the germination would be. And it's important to put those control seeds into a chaff mix because of that potential for suppressing the germination. And also the other critical piece is that we also test against a reference mill. So typically our 2017 model is our reference mill. So that mill's been tested independently through Sam Trengrove and his Saget project over a whole spectrum of weed species. So we use that as our benchmark, and we do side by side what's the new mill technology versus the old technology and against the control. Now the importance there is that if you get a new batch of chaff or a new batch of weed seeds, then the number that you get out of this germination is irrelevant compared to another test, because each batch of seed is an organic, so a ryegrass seed from one season and one location could be larger or smaller than the next batch, and that affects the properties under processing. So a large seed is a lot easier to kill because it's got more inertia against the processing. Also, the moisture content is really key as well. So if you had a bag of seed that had been sitting on the shelf for a number of years and it dried right down to a low moisture content, what happens is the seed can fragment a lot easier. So it's important that you have, to know that you're improving, to have a reference mill each time you do a test. And so what we often look at is not so that, I guess, the kill percentage. What does that mean? It usually means 1 minus the test emergence on the control emergence. And that gives you your kill as a percentage. But the mind plays tricks on you a little bit. So you know, where you'd say 90% and 97%, well, it's, you know, really not that much different. But we tend to try and look at the survivors. So a 90% efficacy is 10% survivors. 97 is 3% survivors, so you're looking at more than 3 times as many survivors with that mill as that mill. So typically we aim to look at this number here, the survivor number, and really push that down as hard as we possibly can, because this actually makes a lot of difference in the seed bank dynamics, which you'll see in another video.